If you take a carboxylic acid and treat it with thionyl chloride, which is SoCl2, you end up getting an acid chloride. The acid chloride is very useful because it's a very reactive functional group that can lead to esters, amides, and then later on, these acid chlorides can also be used to actually add to benzene rings. So, the way this mechanism works is you have your carboxylic acid and you have thionyl chloride. Thionyl chloride is an incredibly strong electrophile. What happens is the electrons from the OH group don't attack the sulfur, but instead they come down here and they kick these electrons from the carbonyl oxygen up to attack the sulfur. And the electrons from the sulfur-oxygen double bond goes up onto that oxygen. And the resulting O- comes down and kicks off a chlorine. Normally you don't want to have an O- and an O positive on the same molecule, but in this case it's okay just because it's a sulfur SO-. We form the sulfur-oxygen double bond, like so. And then the chloride that you liberated comes out, attacks the carbonyl carbon. Electrons go up to the oxygen. And then the electrons from the oxygen here come down and they kick off this oxygen here. This happens to be a very good leaving group, very similar to a tosylated group. You get these two species. This species here, O- comes down and kicks off a CO-, and this gives you sulfur dioxide, which is a gas. It bubbles away, and CO-. And the CO- that's generated comes back, steals this proton here to give you your acid chloride, like so. Now, probably one of the hardest things to recognize is this first step on which oxygen is actually attacking the sulfur, whether it's the double bond oxygen or the OH. Well, to kind of compare the two, say the OH attacked the sulfur. Then the species that you would get looks very similar to the species up above. with one notable exception. The species up above, which I can draw down here, has a carbon-oxygen double bond to the double bond oxygen. While here, this positive oxygen right here is all sigma bonds, single bonds to that. Because you actually have a pi bond here, this species right here is more stable because of resonance. Let's make some space here. These electrons can come down and kick electrons over here. And so as a result, this oxygen, positive oxygen, has two oxygens to share that positive formal charge with. As opposed to the one up here, it has no oxygens to share that positive formal charge. So, long story short, when you do the thionyl-chloride mechanism, you attack the double bond oxygen first.